water hardness. That's what this lab is going to focus on. And before we talk about the lab, and before we talk about the calculations that are needed, we need to figure out what water hardness really is. My water's not hard. I can't knock on it, right? It's a liquid. Well, here's the thing. We use the term water hardness to determine, or to describe really, the concentration of calcium, and there's a sister with it, magnesium, that comes along in your water sample. So, whether you realize it or not, your tap water is full of ions. These can be cations and anions. You've got fluorine in your water because they don't want the teeth to rot out of your head. You have chlorine in your water, maybe due to water softeners, or maybe just due to natural salt intrusion. Maybe it's due to disinfectants, and that's why bromine is in your water as well. You have nitrates and nitrites and phosphates and sulfates and calcium and magnesium and maybe iron and manganese and who knows whatever else is in your tap water. But water hardness typically centers around the calcium and magnesium levels. So if I take these two, calcium and magnesium, and I add those concentrations together, that is what we call water hardness. Water hardness is typically reported in a unit, and that unit is ppm. ppm again means parts per million. Parts per million of what? Well, it's parts per million of calcium and magnesium. Out of the two culprits, calcium is really the one that's the ringleader. So calcium is mainly the culprit for water hardness. However, magnesium is the Robin to Batman and Robin. Magnesium is the sidekick. And magnesium is going to travel along as well. Not in as high concentrations as calcium, but magnesium is in there. So when we talk about total water hardness, we are really referring to both calcium and magnesium. And in order to determine water hardness, we are going to go through this whole thing of a titration yet again. So we are going to have a burette, and in this burette, we are going to fill this full of a titrant. We'll talk about what that titrant is in a minute. Down here below, we are going to have an Erlenmeyer flask, and we're going to have a sample of water in it. And this water, depending on the semester that we do this, could be water from the general public. They have submitted a water sample to us. We want to report total water hardness, so it's very important that you go through as much as the calculations and as much accuracy and as much precision as you possibly can, because we are reporting these numbers to someone if you're doing this during our water study analysis. Okay, so like with any titration, we have a titrant and we have a sample, and we also need some type of indicator as well. Okay, so let's talk about the indicator first. This is called Erychrome black tea, and we abbreviate that as EBT. No, not the food stamp card. EBT. Erychrome black tea. And this crystal is a very dark crystal. It will be a solid. That's what we like to use for our titrations because we think it works better. So this will be a solid, and we will do a little sprinkle of solid. If you read the lab directions, it's going to tell you to add a couple of drops of EBT indicator. Well, this is very similar to phenolphthalein. that it can come to you in a liquid form, but we actually see that this works better as a solid. So we just do a little sprinkle, enough so that we can get a color in our flask, and that's all that we're really looking for. We're looking for the color, right? So EBT is going to be a very dark solid. It will almost be black, or it will be a dark navy blue. And when we put it into the water sample, my water sample will turn, it will be a reddish pinkish color down here below. That's what color that this thing will go to in the very beginning. Okay, so what are the directions? Number one, I'm going to measure out about 50 mils of water. Whatever water sample that is, or whatever sample I'm given, 50 milliliters of it. This can be a graduated cylinder. It does not have to be pipetted. Not for us, at least. Because we are providing a window, a range of soft, moderate, and hard. And we're not really focusing on true concrete numbers. So because of that, 50 milliliters in a graduated cylinder is okay for us to use. Number two, after I add 50 mils of water to the graduated cylinder, I dump it into the flask. Then I add a sprinkle of EBT indicator. And then number three, I'm then going to add a squirt of buffer. Yeah, doesn't this sound like it's very scientific? A sprinkle and a squirt. That's all that you need. Okay, well, bottom line is that this buffer extremely increases the concentration of my pH. My pH is about a 10 with the addition of this buffer. And that's very good because this pH of 10 makes EBT pink in the solution. And as EDTA is added, that is my titrant, drop by drop by drop, this color change will go from a reddish to a bluish. And that blue color is where I need to stop the titration. So when calcium is swimming around on its own without the presence of EDTA, in the presence of this indicator, it has the solution pink. As EDTA is added, EDTA has a reaction with calcium, and it begins to use it up in a way. When calcium is completely used up and there is no more calcium left over in solution, this pink solution goes to a blue solution, and I know to stop. Alright, so let's take a look at EDTA and what it really does. EDTA is called a chelator, or a chelating agent. And what it is this molecule that has these fingers hanging off of it. EDTA stands for ethylene diamine tetraacetic acid. Ethylene, there's a 2-carbon chain in here that's the connector piece. Diamine means that there's 2 nitrogens involved in the center of the molecule. Tetraacetic means that there's 4 acetic groups that are hanging off of this thing. And acid basically means some hydrogens that it can give off. So EDTA is a chelator, which means it captures. And it captures poor little old calcium right here. And it grabs onto it, and it will not let go. EDTA is very commonly found in preservatives. So if you go to your refrigerator and you pull out a food item and you take a look at the ingredient list, I guarantee you that EDTA will be listed on some of those products. If you go to your food pantry and you take a look at your ingredient list, I guarantee you that EDTA will be placed on the ingredient list because it is used as a preservative. It can help capture these cations and maybe anions, but cations really, and prevent them from reacting with anything else. It captures them and it doesn't let them go. So that's the purpose of EDTA. Well, what you need to take home here for the calculations is that 1 mole of EDTA will react with 1 mole of calcium. It is a 1-to-1 ratio. So just like any other titration, if I know how much EDTA that it took, and I know how the strength of the EDTA was prepared, then that relates to the moles of EDTA, which equals the moles of calcium, which can be converted to milligrams of calcium, and then all of a sudden I can calculate a concentration based in ppm, which is milligrams per liter. And that's what we'll go through in the next video when we begin to talk about the calculations. But this is the water hardness titration. It's as easy as that, people. It can't get any easier, right? We have a flask. We put 50 mils of sample in it. We add a little sprinkle of EBT. We add a squirt of buffer. And then the EDTA will be up here in the burette. And I will slowly drip, drip, drip until my pink turns to a blue color. And when that happens, that stops the titration. So in the next video, we'll talk about the calculations. How fun.